Okay, so in this section, I want to take the ideas we've just talked about, the idea of a variable, the idea of satisfaction, the idea of an object satisfying a sentence relative to a variable. And I want to put these two ideas together to help us understand the quantifiers. So the first thing I want to note is that when you think about it, there's a very close relationship between asking when is a sentence with a quantifier true and when an object satisfies a particular kind of sentence. In a way, questions about quantifiers are interchangeable with questions about satisfaction. So let's just take a very simple sentence of first order logic as an x such that h of x. And let's just also compare that with the sentence containing just the variable. This is a thing which is true or false, depending on what the domain is like and how we've decided, what we decided h means. This isn't the thing that can be true or false because we haven't yet decided what the variable picks out. But on the other hand, we can see that there's a very close relationship in the question, is there anything which satisfies this sentence? And the question, is this sentence true? Because they have the same answer. If this sentence is true, if there's something which is h, then there must be something which satisfies the sentence, namely whichever thing makes this one true. So suppose our domain includes A and B. And let's say interpret h as meaning A. We can intuitively see that this sentence will be true because there is something which is h. But likewise, there's also something which satisfies the sentence h of x. Because if we let x stand for A, then the sentence h of x would be true. So if this is true, there must be something which satisfies this. In fact, it obviously works in reverse as well. If there's something that satisfies the sentence h of x, like A, well, that same A will serve to show the sentence including the quantifier is true. So this is an example of how questions involving quantifiers are really interchangeable with questions about satisfaction. If you know the answer to the satisfaction question, you know the answer to this question. If there's anything which satisfies this, then this sentence must be true. And likewise, if that's true, then there must be something which satisfies this. The same thing happens for universal quantification. So let's change the example a little bit. So for all x, h of x, and we'll start with h of x again. The question of whether this sentence is true is really the exact same question as whether everything satisfies this sentence. Because if it's really true that for all x, h of x, let's suppose it were, so we make A and B be the interpretation of x. If it's really true that everything is in h, well then no matter how we decide to assign something to this variable, the sentence would be true. A satisfies h of x, because if we let x be A, the sentence will be true. And B satisfies h of x relative to x, because if we let x be B, it would also be true. So if this is true for all x, h of x, then everything satisfies this sentence. Everything in the domain has to satisfy the sentence. And of course, it works in the reverse direction. If it's true that no matter what thing we pick, no matter what we assigned to x, the variable x, if no matter what we assigned, the sentence would be satisfied, then this has to be true. So if this sentence would be satisfied no matter what, in this case, it means it would be true if we assigned A to x, and it would be true if we assigned B to x. But of course, if that's true, well, then that must mean that everything is h. And so for all x, h of x is true as well. So there's this very close relationship between satisfaction and the quantifiers. Asking the question, how many things are h, like this, is really asking the exact same question as how many things satisfy this sentence. So since there is this close relationship, one way to state the meanings of the quantifiers, what they really mean, is in terms of satisfaction. And this is ultimately exactly why we have variables, because we know the idea of satisfaction is connected to variables. If we then connect the idea of quantification to satisfaction and how many objects satisfy a sentence, then we're going to need variables, because we need variables when we have satisfaction. So let me now state exactly how this relationship goes. And the way we're going to state it is by saying when a sentence, including a quantifier, is true. So let's start with the existential first. We have a sentence like, there is an x such that phi, where phi is any sentence. Remember our rule. If phi is a sentence, then we can add, there is an x such that phi. That's one of our rules. When is that sentence true? Well, it's true just in case there is something that satisfies the sentence phi with respect to the variable x. So for instance, there is an x such that f of x. That's true just in case we could assign x to something and make that sentence true. Universal quantification works in a similar way. So if we want to state the meaning of the universal quantifier, we'll say for all x phi is true. We're going to say the conditions under which it's true. Again, remember, our rule for the quantifiers was that if phi is a sentence, for all x phi is a sentence, then phi can really be anything we want. So for all x phi is true, just in case every object, I should really say in the domain, satisfies phi with respect to the variable x. Or another way of putting it, there's no object in the domain which fails to satisfy phi with respect to the variable x. So for instance, we have a sentence like for all x f of x. What this says is there's just no way of assigning something to x in a way that would make f of x true. No matter who you pick in the domain to assign to x, this sentence would be true. So one thing that's helpful, so I think hopefully that idea makes sense. One thing that's helpful is to go through a particular simple example and explain to ourselves in terms of these definitions why sentences involving quantifiers are true or not. This will be more straightforward in this case because I'm only here going to use sentences including one quantifier and one variable. And what we just want to see in this case is that it kind of explains things we already know. It tells us things that we would have expected to be true, because this is going to help us get our heads around exactly how these definitions work. But later on, we're going to see that when we apply these ideas instead to sentences containing multiple quantifiers, they're going to help make sense of things which otherwise would have been puzzling and which otherwise we don't have an explanation for. And here I'm thinking of this question about the order of the quantifiers. So ultimately, because we have these definitions, we're going to be able to explain what's going on with the order of the quantifiers. Okay, but for now, I want to close out this segment with just thinking about a simple example. So as always, we're going to start by setting up our domain. And again, I'm going to let there be two people, Alice. I'm going to say that the predicate T will intuitively think it means like the predicate is tall. Let's suppose Alice and Bob are both tall. So it's like a set of x where x is tall. We'll say that's equal to the set of Alice and Bob. I'm going to use R for the predicate is rich. And let's suppose, in fact, Alice is the only rich person here. And finally, I'll have the predicate H. Let's intuitively let that be happy. And let's suppose that Alice and Bob are both miserable. irrespective of their levels of wealth. So it's here, this is just the empty set, the set containing nothing at all. Okay. I'll erase this and move this over here. So what I want to do now is I want to use the definitions of the quantifiers in terms of satisfaction to explain why a number of things are true. So if we think about it intuitively, here are a few things that are true. For all x, t of x, we want that to be true. There is an x such that r of x. We want that to be true. It's not the case that for all x, we want that to be true. And it's not the case that there's an x, h of x. So these are all things that we want to be true, which intuitively should be true, given how we understand what the quantifiers mean. And what I want to show you now is that the very simple theory we gave explains why all of these things are true. So let's go through them one by one. What does this say for all x, t of x? What it says is, no matter who you let x be, no matter what object you assign to x, the sentence t of x would be true. In other words, everything satisfies this sentence. Remember, that's what it means to say everything satisfies it. No matter who you pick, no matter who you assign to x, t of x would be true. And here we can see that that's right. Because if we assigned x to Alice, it would be true. If we assigned Bob to x, it would also be true. Because they're both in T, and those are the only people in the domain. Once we've gone through Alice and we've gone through Bob, we've exhausted our domain. There's nothing left. So that's why the universally quantified sentence is true. Everything satisfies this sentence. Alice satisfies it, Bob satisfies it too. Let's now think about the existential quantification. Existential quantification, this sentence says there's something that satisfies this sentence with the variable. In other words, there's something that I could let this variable stand for, and I would then have a true sentence. And of course, that's true, because if x stood for Alice, the sentence would be true. So Alice satisfies this sentence. She satisfies the sentence r of x, and that means there is an x such that r of x must be true. Okay, let's think about the ones involving negation now. These are a little bit harder, but not too hard. These involve a little bit more work. So not for all x, r of x, it says this is false. It's false that for all x, r of x. When we have more complex sentence, the way to think about it is always to break it down. So let's first understand what would it mean for this to be false for all x, r of x, and then we'll automatically know the answer to when this sentence is true. So for all x, r of x says that everything satisfies this sentence, r of x. In other words, no matter who you let x stand for, r of x is a true sentence. That's what that says. So in other words, this sentence is false, just in case there's some way of assigning x to somebody where the sentence would be false. There's some person we could pick to be x, where r of x would be false. And of course, that's true here. We would just want it to be Bob, because Bob isn't in the extension of R. He isn't in what R picks out. So if we assigned x to Bob, R of x would be false, meaning not everything satisfies R of x, meaning the universal quantified sentence is false. So if there's any way of not satisfying this sentence, if there's any person that doesn't satisfy this sentence, that's the whole sentence is true. Okay, let's finally think about the existential sentence. It's saying it's not the case that there's some x such that h of x. And again, if we want to know whether that's true, we just want to think about, is this false? Is it false that there's some x such that h of x? Now, what does that say by itself? There's an x such that h of x says that there's some way there's some person or thing you could assign to x, which would make this sentence true. There's something which satisfies this sentence. So for it to be the case that the whole sentence is false, it must be that nothing satisfies just this sentence. No matter who you assigned x to, h of x would be false. And in this case, we see that that's right. Because remember, h is the empty set here. Nobody is happy in this situation. Nobody's included in that predicate. So if we assigned x to Alice, h of x would be false. And if we assigned x to Bob, h of x would be false. And that's all of our domain. We have nobody else left. So there's no way to satisfy this sentence. So it's false that there's some x, there's an h of x. So not that is true. Okay. So as I said, the answers to all, we can kind of see before we worked through the examples that this would be that all these things would be true. What's important is to be able to explain to ourselves in terms of satisfaction exactly why that works. Because if this is going to be any use to us when we start thinking about complex sentences involving lots of quantifiers, we need to have a grip on how it works in simple cases. If we don't know how it works in simple cases, then there's going to be no hope for us in understanding how it works in more complex cases. Here are two slightly more complex cases, so I want you guys to think about yourselves and how you would answer them. So we're going to keep the case the same domain, predicates are interpreted the same way. I want you to think about these two sentences. There is an x such that h of x or r of x. Think about how would you explain why that's true in terms of satisfaction. And here we got to be careful exactly about which sentence is the one that we're thinking about it for satisfaction and why exactly is it true. So it's a little bit more work to explain exactly why that sentence is true. I also want you to think about this sentence. For all x, it's not the case that h of x. Again, the thing that the quantifier is combining with is a little bit more complex. So I want you to think about how do these ideas about satisfaction and the quantifiers, how do they work when the sentence we're thinking about satisfying is more complicated? Okay, so I'm going to leave those for you, and then we'll talk about them when we meet again in person.